It is time to talk more about erections. Because let us face it, they are pretty important for multiple reasons, especially from the standpoint of reproduction. Now, much of the discussion about erections tends to focus on the male erection. And that may be because the male erection is a little more noticeable than, say, the female erection. But make no mistake, females very much come equipped with functional erectile tissue. But how important is the female erection from the standpoint of reproduction? Because as we have already established, a male erection and the release of sperm cells is pretty critical when it comes to successfully completing reproductive intercourse. So does the female erection and climax also play a key role in that process, or is it more of an added bonus for other reasons? Well, we are about to find out. And we are also going to talk about exactly how it all works. So let us jump right into this reproductive anatomical awesomeness. Now, one thing I want to start with, and this is genuinely fascinating, is that male and female erectile tissue structures are surprisingly similar. Throughout this video, we are going to reference something called homologous structures. For our discussion, these are structures that develop from the same embryonic tissue. So for example, the testes and the ovaries develop from the same embryonic tissue, and are therefore homologous structures. And more importantly, for this erection discussion, the penis and the clitoris are also homologous structures and share the same erectile tissue. So let us start by taking a look at the clitoris, and therefore the erectile tissue, so we can figure out exactly what is going on here. The clitoris is essentially a cylindrical mass of erectile tissue. And as you can see, it is made up of various parts. It arises from two leg-like extensions, and the word for leg in anatomy is crus, or in the plural, crura. So these are called the crura of the clitoris. And the crura are anchored to the ischial and pubic bones on both sides. Now let me orient you on the cadaver dissection. This is an inferior view, meaning we are looking from the underside. And keep in mind, to get to this view, we also had to remove the external genital structures, things like the labia majora and labia minora. You can also see some pretty large muscles here. These are often referred to as the groin or adductor muscles, just for another frame of reference. But here, right underneath my probe, is the right crus of the clitoris. The left crus is covered up by some of the skeletal muscles we left intact on that side. And we will talk about those muscles in just a little while, because they actually get involved in helping to maintain the erection. Now the crura of the clitoris will bend off the pubic bone and come together to form the body of the clitoris. The body of the clitoris is homologous with the body or shaft of the penis. And naturally, the crura of the clitoris are homologous with the crura of the penis. On the cadaver dissection, you can see right here is the body of the clitoris. And the only portion of the clitoris that is externally visible is the very tip, which is called the glans clitoris. No surprise, homologous with the glans penis. The glans clitoris is located at the anterior junction, right where the two labia minora come together at the front. The labia minora are the inner bilateral folds of skin that surround the entrance to the vaginal canal. And going back to the dissection, there is the body, and moving down to the tip, this right here is the glans clitoris. Now the glans is packed with sensory nerve endings. So it is extremely important for sensation, as well as for initiating and maintaining the erection. So how does the initiation and maintenance of an erection actually work? We are going to approach this from two different scenarios. These scenarios can happen independently of each other, but they can also happen together at the same time. The first scenario is simply tactile stimulation, touch of the glans and surrounding genital structures. That sensation sends a signal into the spinal cord through a nerve called the pudendal nerve. Now if you have watched our previous erection video, you know that pudendal translates roughly to that which one should be ashamed of, because apparently the anatomists hundreds of years ago were not too comfortable with their own anatomy. But once that signal enters the sacral portion of the spinal cord, specifically sacral levels S2, S3, and S4, things get moving. When I was teaching this in college, we had a saying, S2, 3, and 4 keeps the penis off the floor. But it works just as well for the clitoris. S2, 3, and 4 keeps the clitoris off the floor too. Now part of that signal will travel up the spinal cord to the brain so that you are aware of what is happening. But it does not technically have to. This tactile stimulation scenario actually works primarily reflexively, meaning the signal enters the spinal cord and most of it gets sent right back out, going directly to the internal erectile tissue of the clitoris. I think of it this way. It is like giving the brain a courtesy notification, hey, something is happening down here, just so you know. But we do not really need your permission. We are going to send this signal right back out and initiate the erection regardless. So someone with a spinal cord injury could technically still get an erection initiated from tactile stimulation alone. But that does not mean the brain does not get involved. It absolutely does. We know that the most powerful erections happen when the brain and tactile stimulation are working together. The brain starts sending signals down. Maybe you see someone who is very attractive, you have certain thoughts, certain imaginations. Even certain smells can be arousing. Maybe someone whispers something in your ear in a very specific way. That signal comes down from the brain and can initiate an erection entirely on its own. And when that happens at the same time as tactile stimulation, these signals converge in that S2, 3, and 4 region of the spinal cord, and are sent out through specific nerve fibers to the internal structures of the clitoris. Those nerve fibers release their neurotransmitters, which then trigger the release of nitric oxide within the erectile tissue. And this is where the magic begins. If we were to take a cross-section right through the body of the clitoris, we would see 2 distinct masses of erectile tissue called the corpora cavernosa. Remember, the crura came off the pubic bone and came together to form the body of the clitoris. And that is exactly where these structures arise from. The corpora cavernosa are vascular, cavernous erectile tissue. Vascular, because there is a large amount of blood that can flow in. And cavernous, because there are hollow spaces, or sinuses, that are going to fill with that blood. Nitric oxide acts as a powerful vasodilator. Meaning the blood vessels within will open up and allow significantly more blood to flow into this erectile tissue. It also relaxes the smooth muscle within, allowing those hollow spaces to expand and fill with even more blood. The result is that the clitoris enlarges. Now, not to the same visible degree as a penile erection, but it absolutely enlarges compared to its non-erect state. So let us come back to the question we started with. How important is the female erection and climax to the successful completion of reproductive intercourse? Or more broadly, to reproduction in general? Now granted, the vast majority of consensual intercourse is not purely about creating a baby. People engage in intercourse for many reasons. It feels good. It relieves stress. It creates bonding and connection between people. There are many reasons. But from a purely reproductive standpoint, getting sperm cells from the male reproductive tract into the female reproductive tract to fertilize an egg, how important is the female erection and climax? Well, you could probably already guess the answer. Technically, it is not required. As long as sperm cells enter the female reproductive tract, fertilization can still occur. Now, setting aside the fact that not having all parties fully engaged is simply bad practice, that does not mean the female erection and climax cannot significantly help the process. And there is one structure we have not yet mentioned, another mass of erectile tissue found on both sides of the vaginal canal, called the bulb of the vestibule. Looking at the cadaver dissection, just below my probe, right next to the crus of the clitoris, is the bulb of the vestibule. On the left side it is partially covered by a muscle called the bulbospongiosus, which is honestly a fantastic name for a muscle covering the bulb of the vestibule. When that muscle contracts, it facilitates the function of the bulb of the vestibule. And when the bulb of the vestibule engorges with blood and becomes erect, it narrows the vaginal canal around the penis, increasing stimulation and helping facilitate climax and the release of sperm cells. Now you could argue that is just helping the male side of things. But if we go a little deeper, some genuinely remarkable things begin to emerge. It is actually known that a female inseminated naturally through intercourse tends to have higher odds of becoming pregnant compared to artificial insemination, all else being equal. Artificial insemination absolutely works. But the natural process tends to have an edge. And researchers believe that edge centers around female climax. Here is what happens during female orgasm, and it is pretty remarkable. The pelvic floor muscles begin to rhythmically contract. And those contractions help propel sperm cells further upstream toward the uterus. The uterine canal also dilates, opening up to allow sperm cells to move through more easily. On top of that, oxytocin is released from the pituitary gland. Oxytocin has many functions, but one of them is causing the uterus to contract. And if sperm cells are already inside the uterus, those contractions help push them even further along, getting them closer and closer to fertilizing that egg. So from a purely reproductive standpoint, female climax demonstrably increases the odds of successful fertilization. The body, it turns out, has designed this process with extraordinary precision. And we could look at this from yet another angle. A female who has had multiple previous experiences of enjoyable intercourse that included climax would likely be more motivated to engage in intercourse again, and more frequently. And more frequent intercourse, as a simple numbers game, also increases the probability of successful reproduction. So whether you look at it mechanically, hormonally, or behaviorally, the female erection and climax are not just a bonus. They are a meaningful part of the reproductive equation. Thanks for watching today. Hopefully you learned something new about reproductive anatomy. Like and subscribe if you feel the need. And we will see you in the next video.